So now we'll do preparation of phenols. First preparation is from aryl sulfonic acids. Aryl means benzene and sulfonic acid will be attached to it. So this is my aryl sulfonic acid. This can also be written as benzene sulfonic acid. Now this sulfonic acid will be treated with NaOH first. Now we know that there is an acidic hydrogen in the sulfonic acid which will get replaced by sodium, and hence it will become SO3Na in the first reaction. So this will form sodium benzene sulfonate, and then it will be again treated with 2 moles of NaOH. Now what these 2 moles of NaOH will do, let's see, if I have SO3Na, NaOH from one molecule, let me just write it this way. So I have SO3Na, NaOH, another mole of NaOH, SO3Na and this Na will go together to form Na2SO3, which I have written it over here. So Na2SO3 will be released. Now we will be left with what? We will be left with OH from this NaOH and NaOH here as a complete thing. So this ONA will go and get substituted over the benzene. So this is forming sodium phenoxide. We have got ONA here and this has become sodium phenoxide, whereas OH of this and hydrogen of another NaOH will release as the water molecule. So next step of reaction will give us sodium phenoxide. This is just a trick. Definitely this is not a way of doing the reaction, or this is not a mechanism of the reaction. This is just way how we can remember that what formed and how did it form. So one Na will get involved in forming Na2SO3. OH of this and hydrogen will come out from another NaOH to form water, and ONA will go and get substituted over the benzene, so forming sodium phenoxide. Now the sodium phenoxide will be treated with any kind of acid which can do further acidification, basically which can replace the sodium from hydrogen. So we have taken HCl here. You can get any other acid also. They may write it as H+. This H+ will go and will replace sodium, and eventually you'll get the phenol. So this is the first method of preparation of phenol. Now come to the next process, that is from aryl halides. The process is called as dose process. All of us know what is aryl halide. Aryl halide means benzene with a chlorine, bromine or iodine. So I have taken chlorobenzene. Now this chlorobenzene will be treated with NaOH again. Now what NaOH will do? This hydrogen of NaOH and chlorine will go together to form HCl and will be released. So reaction between hydrogen of this and chlorine will happen. It will form HCl and ONA will go and get substituted here. So in all of the cases, you will see wherever you have to form the phenol, it will always first sodium phenoxide first, and then you have to do acidification to get phenol. Direct phenol formation is not possible. So here, and this happens in the presence of copper as a catalyst. Okay, so now this will form sodium phenoxide. This is forming sodium phenoxide, and this sodium phenoxide when will get further treated with acid, can be dilute HCl, can be any other acid, it will form phenol and sodium plus will get released. So this is our second method of preparation. Now come to the next method of preparation, and that is from diazonium salts. So now next preparation is from diazonium salts. All of us know what is diazonium salt. Benzene with N2X. Benzene with N2X group is called as diazonium salt. Where has a diazonium linkage, we have N double bond N X, and then with this link it is attached to the benzene chain. So this is our diazonium compound. We have done this in the haloalkanes chapter also. So in haloalkanes chapter we used to get haloarene using the diazonium salt, and how we used to do it? We used to do Sandmeyer's reaction and Getterman reaction by reacting it with CuCl or by reacting with Cu plus HCl, which used to replace this whole N2Cl with the respective halogen, and nitrogen gas and the other CuCl2 or CuBr2 or CuI2, CuBr, Cui or CuCl used to get released depending upon what is the halogen group present over here. So that was the method of preparation of haloarene. This is the method of preparation of phenol. So we have taken benzene diazonium chloride here, benzene diazonium chloride, and we have heated it with water. So this water, what this water will do? So from this water, OH will go and replace this N2Cl. So you will get a phenol. One of the hydrogen will go along with the chlorine to form HCl, and this nitrogen gas, nitrogen will come out as a nitrogen gas. Whenever the reaction of diazonium halide is happening with benzene diazonium halide is happening with any of the compounds, to form the other form of benzene derivative, always N2 gas will get released. This is always going to happen. So bond between benzene and N2 will break, N2 will go out as a gas and the other substitution will take place. Now come to the next preparation of phenol. This is by decarboxylation of sodium salt of salicylic acid. First of all, in this we need to know what is salicylic acid. Salicylic acid is a compound of phenol with the carboxylic acid on it. So this is my salicylic acid. This is salicylic acid. Okay. So when I say that this is a sodium salt of salicylic acid, what do we need? We need to put sodium instead of hydrogen. So now it will become the sodium salt of salicylic acid, Na salt of salicylic acid. Now when we are talking about this compound, we have written in the method that this is a decarboxylation. If you remember, we have done the decarboxylation in the previous chapters also when we were doing the preparation of alkane from a carboxylic acid. So what we used to do, this we have done in grade 10th also. So we have a carboxylic acid, we will form a sodium salt of carboxylic acid, then we will treat it with soda lime. Soda lime is what? NaOH and CaO, and we will heat it. So this NaOH and CaO, this Na of this, sorry, this CO, Na and this Na will go together to form Na2CO3. This NaO and CONA will go together and form Na2CO3. This hydrogen goes and make the place where the CONA was present, that becomes alkane by the replacement of hydrogen with this whole group. Okay, so whenever we have, this is not only for this, but this is for any RCOONA. If you have treated it with NaOH plus CaO, this RCONA and NaO used to go together to form Na2CO3. CO used to act as a catalyst and this R used to become RH. So irrespective of whatever the sodium salt of carboxylic acid is, if we are using soda lime, it will behave in the exactly same manner. So NaOH will give its NaO and CONA it will take out and will form Na2CO3. This hydrogen will go and will replace this CONA at this position, will form the alkane at this side. Okay, so this is what exactly we are doing over here. So this is what happening. We have a OH and CONA over here. NaOH is getting treated. CuO, the reaction happens in the presence of this is not this is CaO and CuO both. Copper oxide is required because that acts as a catalyst. Okay, so now and we are heating it together. So this CONA and NaOH goes together forming Na2CO3. Hydrogen comes and makes it an alkane. But because there is an excess amount of NaOH, Na of NaOH, the another molecule of NaOH, replaces the acidic hydrogen of phenol and forms it ONA. That is a generic process. If Na is there in the system, it will replace the acidic hydrogen. If the Na is there on the molecule and acidic hydrogen is there, that will replace the sodium. So that keeps happening. That always keeps happening. So this has formed sodium phenoxide here. We could have directly got a phenol over here, but because of the presence of NaOH, the acidic hydrogen of OH also got replaced by sodium. So we have to further treat it with the acid. So now ONA will get further treated with any acid like dilute HCl and will form phenol plus Na plus. Okay. So this is the fourth method of preparation. Now let's do the fifth method of preparation, that is from Grignard reagent. So next preparation method is from Grignard reagent. We all of us know what is the Grignard reagent. Benzene based Grignard reagent will be benzene with MgBr or MgX. So this is our we can write it as phenyl magnesium bromide, phenyl magnesium bromide. Okay. So now if I react it with O2, which is present in the air, this O2 will go and get fit in between the bond between carbon and magnesium. So out of two oxygens, one oxygen will come, that's why we have written half O2. That one oxygen will come, will break the bond between carbon and magnesium, will fit in between and will form this kind of intermediate species. Now this species, let me check what it is called. It is called as phenoxy magnesium bromide. Phenoxy magnesium bromide. Now we know after this what needs to be done. Once this is formed, we have done this in the other Grignard reagent reactions also. We will do the acidified hydrolysis. H plus will go and replace this MgBr. MgBr will go out forming MgBrOH and the hydrogen will come instead of MgBr. So this is a usual process of forming a alcohol from a Grignard region. This we have done multiple times before. So phenol formation will happen. So these all are the preparation methods what can be done in the laboratory to form the phenol from any other benzene based compound. Now come to the commercial method of preparation. That means on the large scale if we have to prepare phenol, these are the methods what we will be following. First method is from cumene. First of all, you need to know what is cumene. Cumene is isopropyl benzene. Isopropyl benzene. So what do we mean by isopropyl benzene? I should have a benzene and isopropyl group attached to it. Isopropyl is the group or iso is a term which we use when a second carbon of the carbon chain is attached to something. Okay, so I have a propyl chain. Propyl chain is the chain made up of 3 carbons. So second carbon of your propyl chain will be attached to the benzene chain. So it will be CH3 CH CH3. This is your isopropyl group. Okay, and this is called as isopropyl benzene. This particular compound is called as cumene also. Remember this is a very important compound. Now how to prepare cumene first? Though we can get a reaction from this part, that is once the cumene is formed, or they may give you the reaction where cumene has not been formed yet. They give you the starting compounds to form cumene and then do the reaction further. Okay, so we have a benzene and we have a propene. Now this benzene and propene will do the reaction, will be reacted together or heated together in the presence of H3PO4 or AlCl3. AlCl3 generally helps in doing the isomerization and all those processes where the rearrangement of carbon atoms all can happen and one form of a compound can get converted into another form. So this also helps in the adding this particular propene chain over the top of the benzene. Okay, so this propene gets hydrogen from an acid, becomes CH3, and this carbon gets attached, or you can also call it as that the benzene's hydrogen comes out, gets added on the carbon over here, forms CH3, and this carbon gets attached from that point to the benzene. So basically I had a structure like this. I had a benzene with hydrogen and I had CH3 CH double bond CH3. So this hydrogen will come out as H plus will go and get added over here. Okay, so that means this carbon, when the hydrogen will get added over here, it will form CH3 CH plus and this is CH2. So this will form CH3, and when the hydrogen will leave benzene, there will be negative charge over here. So carbon on the benzene will have a negative charge, and the carbon, which is the center carbon of your propene chain, will become positive, and hence these two will attach and will form a cumene. Okay. Now the addition of oxygen will happen. Now how the addition of oxygen will happen? Oxygen has oxygen double bond oxygen. First of all, the bond between double bond between oxygen and oxygen will break and only one bond will be left. One bond will become free. Other side of for the other oxygen also one bond will become free. Now from this kind of structure, it will try to attack on the center carbon. Now how it will try to attack? We have a hydrogen over here. Let me rewrite it. So this is how the bond is. Carbon hydrogen is linked to each other. I have oxygen, single bond oxygen with the empty 2 valencies. First of all, the bond between carbon and hydrogen will be broken. Okay. So now my carbon will look like, I'll just write it here. So it will be like this. Carbon with CH3 and CH3, and there is a 1 valency free. Hydrogen has assumed it has come out. Okay. Now this oxygen with the free valency will come and attach over here, forming oxygen and a free bond over here. The hydrogen which has got released from the carbon, that will come and attach over here. So this is how the setup will look like. This is how this intermediate will be formed. Clear this part? Now once this intermediate has been formed, then it will be treated with a dilute H2SO4. Let me just rub the down thing, otherwise you will get confused. So it will be treated with the dilute H2SO4. Now how dilute H2SO4 will help? It will help in breaking this CH3CO. This whole thing it will break off. This whole thing will come out from the benzene chain. So if it will come out, just understand. So what will happen? The bond between carbon and this carbon of this isopropyl and the benzene carbon will break. So I will get the molecule like this. This is how the molecule will come out. Once it will come out like this, one free valency will be with oxygen, another free valency will be with carbon. These 2 valencies will combine and will form an acetone. Right? Now, this OH which has got formed, that OH will go and attach on the benzene, forming phenol. So what we have done, first of all, we have formed cumene. Then in cumene we have added oxygen. Oxygen has formed this kind of peroxide linkage. Then this peroxide will further react with dilute H2SO4. Dilute H2SO4 will help us in getting rid of this acetone part, and then we'll get a phenol. So this is one of the important methods to manufacture phenol on the large scale. Now let's do the second method. So next is from benzene, that is Rushig's process. Preparation of phenol from benzene in the manufacturing process is called as Rushig's process. Rushig's process. Okay. Now here, what we have done is, I think I have done a mistake. This should be only benzene. So I have taken a benzene, and then this benzene is treated with oxygen, that is in the presence of air, and HCl. Okay. So oxygen from the air and HCl we have taken. Now when the benzene reacts with O2 and HCl in the presence of copper chloride and FeCl3, both are acting as a strong catalyst over here, and the temperature required is also a very good temperature, nearly 650 Kelvin. Now then this reaction takes place, the chlorine gets attacked on the chlorine attacks on the benzene and form the chlorobenzene. So this is a chlorination of benzene process. Though we have learned many other processes of chlorination of benzene or halogenation of benzene, this is the one what we use in the Rushig's process. So we cannot replace it with any other reaction, because this is a named reaction. Named reaction means a certain set of steps we have to follow in exactly that manner how it has been described in the books. So HCl is giving its chlorine, forming a chlorobenzene, and hydrogen and oxygen going together to form a water molecule. Okay, this is the first step. So chlorobenzene has been formed. Now this chlorobenzene will be treated with the steam, that means H2 at a very high temperature, nearly 750 Kelvin, and then this OH from the water, OH will replace chlorine, and one hydrogen will go along with the chlorine to form HCl. So this is the second step. So this is one more important method of manufacturing phenol on the large scale. The third method is taking directly benzene, treating it with oxygen at a very high temperature in the presence of a catalyst V2O5, vanadium oxide. Vanadium oxide has used as a catalyst in many other processes where we had to do the polymerization of smaller chains to convert them into benzene or the benzene based chains. Okay, so vanadium oxide is a very common catalyst what we use for benzene based reactions. So benzene will be reacted with oxygen in the air, and it will be heated at a very high temperature, closer to 800, 900, and then vanadium, in the presence of vanadium oxide, it will directly get converted into phenol. So either of these three methods you can use to prepare phenol in the larger scale. Okay, here we are done with the preparation of phenols. Next we will be doing chemical properties and physical properties of phenol.